In this lesson, we're going to talk about gases and moles. So we're going to learn one last conversion factor, and then we're going to do some practice problems with it. Before we can begin, we need to review what a gas actually is. So remember, a gas is just a state of matter, so there's solid, liquid, gas, plasma. A gas is the state of matter in which the particles fill any container and bounce off the walls of that container and into each other. So they're particles that are zooming around super fast, and the more temperature you add, the more quickly they move, etc. And some examples would be oxygen, carbon dioxide, helium, things that are red on the periodic table. So things that appear in the squares in their classroom that are red on the periodic table in the classroom, those are gases at room temperature. It has been found that 1 mole of any gas has a volume equal to 22.4 liters of that gas. So 1 mole of any gas ever has a certain volume, and this volume always stays the same. So just like Avogadro's number, 22.4 is going to be a number that you need to get into your head. So to your mole map, I want you to add another circle coming from moles that says liters. And remember, that's just for gases, so liters of a gas. Now, the conversion factor that you're going to use along this bridge is that 1 mole is equal to 22.4 liters. So again, that number 22.4, and it's really important. So your conversion factor up here is 1 mole is equal to 6.02 times 10 to the 23rd atoms. And here your conversion factor is 1 mole equals the number from the periodic table in grams. So now we have 3 conversion factors. And in your conversion factors, only the number that comes from the periodic table changes. 22.4 and 6.02 times 10 to the 23rd never ever change. Whenever you use atoms, you always are going to use Avogadro's number. Whenever you use liters, you're always going to use 22.4. The only number that you have to look to change sometimes is the number from the periodic table, which remember we call the molar mass. And for elements, it's just the number below the symbol in the square on the periodic table. But for compounds, it's the sum of the individual molar masses of each element that are in the compound. So let's do a practice problem. This says how many moles of oxygen gas are in 44.8 liters. So if we write the number and unit we're given, 44.8 liters of oxygen, and we remember our conversion factor that 1 mole of any gas is equal to 22.4 liters of that gas. We can put 22.4 liters of oxygen equals 1 mole of oxygen. So if you do 44.8 times 1 divided by 22.4, you get 2 rounded to sig figs 0.00 moles of oxygen. The next example problem is how many grams of oxygen gas are in 67.2 liters. So if we start with the number and unit we're given, 67.2 liters of oxygen, we first remember our conversion factor that 1 mole of any gas is equal to 22.4 liters of that gas. So 1 mole of oxygen is 22.4 liters of oxygen. So right now, if we were to stop there, we would end in moles of oxygen, but I want grams of oxygen. So I need to now go to the periodic table, because 1 mole of anything is equal to the number from the periodic table in grams. However, oxygen is a special case. Oxygen, when it's by itself, it's never just found as O in nature. So when it's oxygen gas, it is found as O2, which means there are 2 oxygen atoms in the compound, even though it's not really a compound because it's only one type of atom. So oxygen by itself, in 1 mole of oxygen gas, there are actually 32.00 grams of oxygen. So if you look at the periodic table, the square with oxygen in it has 16.00 in the bottom. But because oxygen is found as O2 in nature, it's really 16 times 2, because there are 2 oxygens. So when we write that, we'll write it as 32. This is called diatomic, which I'm going to go over in just a second. But if you do the math on that, 67.2 divided by 22.4 times 32, you get 96 grams of oxygen. 96.0, excuse me. There are a total of 7 of those elements that appear with a partner every time that you find it in nature. So oxygen, we already talked about, is found in nature as O2. Hydrogen is never found by itself. It's also found as H2, or with a partner. Nitrogen is found as N2. Fluorine is found as F2. Bromine is found as Br2. Chlorine, Cl2, and iodine, I2. So anytime that you're doing any calculations with any of these 7 elements, they're always referred to as diatomic. You always have to double the molar mass. Let's do another practice problem. How many grams of nitrogen gas are in 11.2 liters? Well, we're going to start with the number and unit given, 11.2 liters of nitrogen, which when it says nitrogen gas, it means nitrogen by itself, which we know nitrogen is one of the 7 diatomics, so it exists as N2. The 7 diatomics you're just going to have to memorize. So this number and unit, 11.2 liters of N2, we first need to convert to moles, and we remember that 1 mole of any gas is equal to 22.4 liters of that gas. So 1 mole of N2 is equal to 22.4 liters of N2. Now we're in moles of N2, but I want grams. And every 1 mole of N2, if we look at the periodic table, nitrogen has an atomic mass, or molar mass, of 14.01 grams per mole. But because it's N2, we have to multiply that times 2, so we get 28.02. So then when you do the math, you get 14.01 grams of nitrogen, which this is grams of nitrogen. Moles cancels out.